This presentation is designed to introduce you to the latest LANDFIRE products. The goal is to help you understand the evolution of the products, their strengths, weaknesses, and underlying assumptions so that you can successfully and appropriately apply them. This particular presentation was developed with specific examples from the Pacific Northwest, but all the general information applies across the country. I will begin with a version comparison that highlights the major LANDFIRE versions to provide some context, and then we'll dive right into the details of the 2001 and 2008 products. There are several versions of LANDFIRE products available. This table provides an overview of the major versions. We will get into the details later, but I want to draw your attention to a couple of items before we do that. First, notice that the imagery date does not change between the versions. Newer imagery was used only to remap areas where change was detected in the 2008 products. Next, notice that the products are current as of different dates. The national and 2001 versions are both current as of 2001. The difference is that the 2001 dataset incorporates some important mapping improvements. The 2008 data reflect landscape conditions as of 2008. Finally, notice that there have been changes in the methods for calculating vegetation condition class, a product we used to call fire regime condition class. We will discuss these changes in detail later in the presentation. Now that you've seen the versions, you might be wondering, which one should I use? Most users will want to use the most current version, that is, LANDFIRE 2008, unless there is a specific objective that requires older data. The reason for providing information on the older products is so that you can see what has changed over time and understand how those changes might affect your use of LANDFIRE data. Let's start with the changes made to the LANDFIRE 2001 products. The primary goal of LANDFIRE 2001 was to provide a foundation for the LANDFIRE 2008 products. That was done by making a series of improvements to the original LANDFIRE national products, many of which were suggested by LANDFIRE data users. Changes include a set of systematic improvements, remapping of forest cover and height, remapping of western rangelands, grouping biophysical settings, and producing new fire regime layers based on the grouped biophysical settings. These are some of the systematic improvements. Adjustments were made to make LANDFIRE maps coincide with existing data sets along the international borders. The LANDFIRE 2001 maps are synchronized with the National Land Cover Data Set, or NLCD 2001. LANDFIRE uses the NLCD to map certain existing vegetation classes, but during LANDFIRE National, NLCD 2001 was only partially complete, creating inconsistencies in land use classes between the final NLCD 2001 and the LANDFIRE National layers. Changes resulting from the use of the final NLCD 2001 product include adjusting the extent of barren, rock, water, wetland, and riparian land cover types. In LANDFIRE National, areas classified as agriculture or urban were not assigned a fuel model. In the 2001 and 2008 products, this was changed in protected landscapes to reflect situations where some agricultural and urban lands are managed as natural lands or are in a burnable type. This map illustrates the reclassification of some agricultural pixels from a non-burnable to a burnable designation in the fire behavior fuel model layers. The red and brown areas on this map were classified as agriculture in the existing vegetation map. The red areas were given a fuel model assignment. These areas include agricultural classes such as idle cropland, pasture hay, and orchard. The brown areas did not receive a fuel model assignment and include agricultural classes such as row crops. In this particular example taken from Central Oregon, the impact of this change in fuel model assignments appears to be relatively minor. In other parts of the country, the change in fuel model assignment may be more significant. LANDFIRE received user feedback that tree canopy cover was generally too high. For 2001, we used a new methodology for mining information from the forest inventory and analysis plots and a stem mapping algorithm to improve vegetation cover mapping in forested areas. In the Pacific Northwest, the result of this change is more area mapped into the mid-range cover classes and less in the high cover classes. The change in vegetation cover distribution should align better with the values expected for fire behavior modeling. LANDFIRE developed a new height mapping technique for its 2001 product that incorporated user feedback and additional data sources. The 2001 product represents the average height of the dominant and codominant trees in a stand, whereas the LANDFIRE national data estimated the average height of all trees. In the Pacific Northwest, the result of this change is more area mapped into the taller tree classes. The new height map should align better with the values expected for fire behavior modeling. For certain mapping zones in the western half of the country, grassland and shrubland biophysical setting map units were remapped using SURGO, or Soil Survey Geographic data, that were not available in the West for LANDFIRE National. LANDFIRE National used the coarser StatsGo, or State Soil Geographic data. An effort was made to simplify the BpS classification and associated state and transition model set from which LANDFIRE reference conditions are derived by adding a group attribute to the 2001 and 2008 BpS products. A rule set was applied for grouping the BpS models. Models could be grouped if they were identical, or if they were similar and had the same fire regime group, if they had the same or a similar number of succession classes, and if they had similar reference conditions. When models were grouped, one of the LANDFIRE national models was chosen to represent the group, and a new group name and number was assigned in the BpS map attribute table. This slide shows a visual representation of the grouping process. On the left are 3 ponderosa pine BpS that met the criteria for grouping. The one in the middle was chosen as the exemplar model. It was assigned a group name and number, and its associated S-class definitions and reference conditions were used for S-class mapping and vegetation condition class calculations. Note that the BpS map attribute table for all versions of LANDFIRE includes both the original BpS name and the group name. This provides users with 2 different BpS classification schemes to explore and use. However, it is important to remember that the BpS map and the BpS reference conditions are inputs into the fire regime products, including succession class, vegetation condition class, fire regime groups, and the historical fire regime maps. In LANDFIRE 2001 and 2008, these maps were based on the group BpS and its associated exemplar model. LANDFIRE National only delivered the fire regime products for the conterminous U.S. LANDFIRE 2001 and 2008 delivered these products for the entire U.S., including Alaska and Hawaii. In addition, LANDFIRE changed some of its terminology to better match the Fire Regime Condition Class Guidebook. FRCC Departure is now called Vegetation Departure, and FRCC is now called Vegetation Condition Class, or VCC. These changes reflect the fact that LANDFIRE's products only represent the vegetation part of the FRCC equation. In LANDFIRE National, fire frequency and severity from the BpS models created with the Vegetation Dynamics Development tool were used as inputs to the LandSum landscape succession model, which was used to map the reference fire regimes. In LANDFIRE 2001 and 2008, the fire regime groups, fire frequency, and fire severity maps were derived directly from the Vegetation Dynamics Development Tool models associated with each BpS group. LANDFIRE National calculated vegetation departure and condition class for each ecological subsection within a mapping zone. 2001 and 2008 LANDFIRE products summarized departure within hydrologic unit codes from the NRCS watershed hierarchy. Recall that vegetation condition class is a scale-dependent metric, so changes in the summary unit can affect the departure calculation even if the input data do not change. It is theoretically okay to compare the 2001 and 2008 vegetation condition class data sets because they were calculated using the same methods, but be aware that it may be too short a time period to see substantial changes unless you are analyzing individual watersheds where recent large disturbances have occurred. 2001 and 2008 vegetation condition class maps should not be compared to earlier versions because of the changes in the summary unit and the use of the BpS groups. This concludes Part 1 of this presentation. Please continue to Part 2 for detailed information on the 2008 products.